So in the last video, we've seen the definition of standard deviation. So here we will see the practical way of calculating the standard deviation. Again, standard deviation is nothing but it will let us know the distribution of your data. So how far your data is distributed. So the formula is that standard deviation is square root of sum of your squares. Okay, so sum of your xi minus mu the whole square divided by n. Okay, so we'll understand each and every element in the formula. So xi, as I was telling, the standard deviation formula will include each and every data point in your data set. So xi is your each and every data point minus mu, the average, and divided by total number of observation. So by definition, by formula, so each and every point we are calculating the distance. Distance of what? From the mean position. Okay, so let's say for an example, so this is your average point, average of all the points. So we are calculating, say, let's say these are the points, your points after marking in the graph. So we are calculating the distance of each and every point from its mean position. Okay, so that's why the standard deviation is widely accepted measure for your the distribution of your data. That is why, because of each and every point is included in the calculation. So let's quickly see how we can calculate the standard deviation. Let's take the data. Consider that you have collected people who are exercising minutes. Okay, so random minutes. So some people, they exercise 20 minutes, 25 minutes, 30. Okay, so you've gathered the workout minutes, okay, from the customers. So how many observation do we have? We'll keep 10 observation. So n here number of observation. So let's mark it down. So n equal to 10. Okay, so what is 10? Number of observation. And let's go component. Okay, let's see the first component, xi minus mu. So for that we need average of your data set. So let's calculate mu. Average of my data set is 29.5. So let's write down here average equal to 29.5. So the first one is xi minus mu. So let's calculate one by one equal to x each and every point minus my average. So I'm fixing the average using dollar symbol. So 20 minus 29.5, 30 minus 29.5. Okay, so you're gonna get this. Each and every value is included in the formula and you got the answer. So what is the second part of the formula? Whole square. So the entire thing you have to do the whole square. Again, we have to understand why we are doing the whole square. So if you see here, it is one is in the negative direction, that is minus 9.5, and here it is 20.5. So in order to normalize it and bring it into one scale, so we are doing whole square so that minus into minus will become plus. But we are not changing the value at all, if you notice. Okay, the value remains same, but we are only changing the direction of your data set. So your answer into the answer. So whole square. So you're just normalizing your data set. Okay, so we've got the calculation part. So what is the second part? Summation of everything. So add everything. Okay, so add all the distance. So what is, as of now, what we have calculated? So let's say your mean point here is 29.5. And each and every point, so this is 20, and this is 10, and this is 50. So you've calculated the distance from here to here. And we have normalized the direction part, and we eliminated the minus symbol. And the last part is summation of everything. So add everything. So addition 1672.5. Okay. So this is the numerator part. Equal to sum of your answer, that all the data points 1672.50. So the sum of squares divided by n. Okay. Number of observation equal to this divided by 10. Okay, so you got the variance, and now you have to calculate the standard deviation. The standard deviation equal to square root of your variance. So square root of your 167.25. So 12.93 is your standard deviation. So let's verify with your system inbuilt formula, Excel formula. So 12.93. Okay, so if you learn this step by step, it's going to be easy. So as per the formula, so we are just calculating the distance of each and every point from the mean position, and we are dividing everything, the whole sum divided by number of observation. So this is your standard deviation.